Okay, we're continuing our study in trigonometry with this lesson 9.3, trig functions of general angles. So let's just get right into it. We need to set this lesson up by taking a look at the coordinate plane and the four quadrants, as I've labeled them here, quadrants 1, 2, 3, and 4. And just a quick review of the signs of the ordered pairs within each quadrant. And then we're going to make a connection to the signs of trig ratios within each quadrant. So within quadrant 1, if we were to write ordered pairs like this, the x-coordinate would be positive, and so would the y. Okay? Let me help you out with the signs of trig ratios within each quadrant. You can always associate the cosine function with the x-coordinate. So just like x is positive in quadrant 1, cosine is also positive in quadrant 1. You can also associate the y-coordinate within each ordered pair with the sine function. So just think, cosine corresponds to x, sine corresponds to y. Okay, so both cosine and sine are positive in quadrant 1. Let's go one step further. Tangent is the ratio of sine over cosine, or you can think of it as the y-coordinate divided by the x-coordinate, and since y and sine are basically synonymous, you can think of it as sine divided by cosine. Well, a positive divided by a positive is positive, so the tangent ratio is also positive in quadrant 1. Okay, let's move to this first quadrantal angle at 90 degrees. And I'm just going to use the ordered pair 0, 1 to illustrate. Well, remember, cosine corresponds to x, sine corresponds to y. You can just remember it this way. If you use the ordered pair 0, 1, and I'm basically giving you a little bit of a preview of something we call the unit circle. At this angle 90 degrees, cosine is always 0. Sine is always 1. Okay, cosine is x, sine is y. At 90 degrees, that means cosine is 0. Sine is 1. Okay, positive 1. Tangent. Remember, tangent is the ratio of y over x. Well, understanding that we cannot divide by 0, which is what we would be doing with the tangent ratio for the 90-degree angle, y divided by 0, so tangent is undefined at 90 degrees. Alright, so we'll just keep working our way around. Let's go to quadrant 2. In quadrant 2, if we were looking at ordered pairs, the x-coordinate would be negative and the y-coordinate would be positive. Well, just think of that when you think of cosine and sine. Cosine is negative because it corresponds to x of the ordered pair. Sine is positive. Cosine negative, sine positive. Okay, and so let's go to tangent. Tangent is always y over x, and since the y is positive and the x is negative, that means tangent is negative in quadrant 2. Anytime you have positive divided by negative, that makes negative, so tangent is negative. Cosine is negative in quadrant 2, just like the x is negative. Sine is positive in quadrant 2, just like the y is positive. Tangent is the division of y over x, or you can think sine over cosine. In either case, a positive divided by negative makes a negative, so tangent is negative. Alright, so let's move to this next quadrantal angle and I'm just using a radius of 1 going all the way around. So this would be the point -1, 0. And this is the angle 180 degrees, or in radians we mentioned earlier it would be pi. In radians up here this would be pi over 2, half a pi. Okay, so remember, cosine is x, sine is y. So for 180 degrees, cosine is -1. Sine is 0. That's always true. It's always true for the 90-degree angle that cosine is 0, sine is 1, and tangent can't be done because we can't divide by 0. Here, cosine corresponds to x, sine corresponds to y. That's always true. Tangent will be the division of sine over cosine, or y over x, and in this case we just get 0. So at 180 degrees, or pi in radians, tangent is 0. Okay, down here in quadrant 3, in the ordered pairs, x and y are both negative. That means cosine is negative in quadrant 3, so is sine. However, tangent, which is sine divided by cosine, or you can think of it as y divided by x, negative divided by negative is positive. So tangent happens to be positive in quadrant 3. And hopefully this is going to make a little bit more sense when we build on it and start doing some homework, but I need to lay this foundation first. It's important that you understand the connection between the x coordinate and cosine, y and sine. If you know the signs of the ordered pairs all the way around, then you know what cosine is as far as the sine of cosine and the sine, S-I-G-N, of sine. And then you can do the ratio to get tangent. Okay, let's talk about this quadrantal angle. So here we are at 0, -1. Okay, well once again cosine is 0 because it corresponds to the x coordinate. Sine is -1. Tangent once again is undefined because when you divide -1 by 0 you can't divide by 0. So tangent at 270 degrees, or 3 pi over 2, is undefined. And then we're over here in quadrant 4, where the x-coordinate would be positive and the y-coordinate negative. That means cosine is positive in quadrant 4, sine is negative, and tangent is also going to be negative because when you do sine over cosine, negative divided by positive is negative. Okay, so that's just a brief run through, but this is so important for what you're going to be doing throughout this lesson. I just wanted to lay some groundwork. Let's go ahead and complete our ordered pairs here on the quadrantal angle. So here we are at 1, 0. So this is the 2 pi or 360 degrees, or you could think of it as 0 degrees as well, because either one's applicable. So at 0 degrees, cosine is 1, sine is 0, and when you do 0 divided by 1, which is what tangent would be, tangent is 0. So tangent is 0 both at these locations on the x-axis, 0 degrees, 360 degrees, 180 degrees. This is also 2 pi radians. But on the y-axis, since we can't divide by 0, tangent is undefined, both at 90 degrees and 270 degrees. All right, so what does that all mean for us in our homework? Well, let me show you where this is going to be important. The terminal side of some angle called theta in standard position contains each point. Okay, so what I'm going to do, first of all, is I'm going to do my xy plane, and I'm going to put the point 1, 2, doesn't have to be anything fancy. I'm going to put the point 1, 2, And what it's saying here is that theta comes out of the origin and it goes through that point 1, 2. All right. And so what we're supposed to do is find the exact values of the 6 trig functions of theta. What we need to do is come up with a right triangle using this point 1, 2, and we're just going to drop down a side to complete the right angle, and here's theta. Okay, theta will always be near the origin. It will be the angle that's formed with the initial side, like we talked about earlier in lesson 1, and this other terminal side coming out of the origin. All right, so here we have our right triangle, and if the point 1, 2 is here, that means that this side of the triangle has a measurement of 1. This leg here at the bottom, because my x-coordinate is 1 and the y-coordinate is 2, that means this leg of the triangle has a measurement of 2. Okay. What we don't know is the length of the hypotenuse, the side that's across from the right angle. So we're going to have to rely on the Pythagorean theorem again. C squared is equal to a squared plus b squared. C squared is equal to 5, so c is the square root of 5. All right, so now I know that this side, this hypotenuse that I had labeled as c, is measured at the square root of 5. Okay, now I can get all of the trig ratios, all 6 of them that relate to this angle called theta. All right, so remember it's sine theta, cosine theta, tangent theta, and then we'll get the reciprocals of those. The reciprocal of sine, remember, is cosecant. Cosine is secant. And tangent is, of course, cotangent. All right, so let's work on these ratios. Sine, again, we're looking out from theta's point of view, this angle that I've identified here near the origin. Sine is opposite over hypotenuse. So I'm going to start it over here because we're going to have to rationalize. Opposite, which is 2, over hypotenuse, which is square root of 5, and always rationalize. All right, so here I have 2 square root of 5 over 5. That is the sine ratio for theta, or the sine function for theta. Let me just move these over. I just paused and repositioned these so I'd have a little bit more room to write answers, but hopefully you saw how we came up with sine, 2 root 5 over 5. And now let's work on cosine. So for theta, cosine is adjacent over hypotenuse. And so once again, we rationalize and we get the square root of 5 over 5. That's the cosine function. Tangent is for theta, or for any angle really, it's the opposite side over the adjacent side. So it's 2 over 1, which is just 2. Now we just get to do the reciprocals. So remember, the reciprocal of sine is cosecant. So here's where I came up with the sine ratio. It's 2 over the square root of 5. So for cosecant, I'll just flip this over and do the square root of 5 over 2. Cosine has its reciprocal, and it is secant. So here's where we figured up the cosine. We started off with 1 over the square root of 5. Well, for secant, we just flip that over, and we get the square root of 5 over 1, which is just the square root of 5. And cotangent is the reciprocal of tangent, and if we take 2 and flip it over, we get 1/2. And so that ends up being my final answers. And the thing that you have to be careful with is when you're in quadrant 1, it's no problem. Remember that in quadrant 1, everything's positive. Cosine, sine, tangent, all the reciprocals, everything's positive in quadrant 1. So I've double checked, I've come up with the ratios, and sure enough, I've made sure that every ratio is positive since this point lies in quadrant 1. What about if the point doesn't lie in quadrant 1? So let's take a look at an example. I think you're probably better off if you go ahead and draw just a rough sketch of this. The point -8, -15, I'll just say this doesn't have to be anything fancy. Here's -8, and we'll put -15 a little bit lower. Obviously, that's going to be in quadrant 3. So here's the point, -8, -15. My angle, the terminal side of that angle goes through that point. All right, so this is my angle theta. And I'm just going to drop a line to create a right triangle. Okay, so here's my right triangle. And once again, I know 2 of the sides based on this point. I know that this leg has to be measured at 8, and I know that this leg has to be measured at 15. Okay, the length of this leg of the triangle has to be 15. This one has to be 8. Once again, I don't know what the hypotenuse is, so let's use the Pythagorean theorem. C squared equals 8 squared plus 15 squared. Grab our calculator. You get C squared equals 289. And you do the square root of 289. Grabbing my calculator here, square root of 289. And that is 17. So C measures at 17. That's the hypotenuse. And now that we have all of our sides labeled, we're now able to do all of the trig ratios. But you've got to be careful, because remember, in quadrant 3, since both of these points, x and y, are negative, that means cosine, which corresponds to x, is negative. And sine, which corresponds to y, is also negative. But when you put tangent, which is sine over cosine, or y divided by x, tangent will be positive. So we got to be careful that when we come up with the ratios, we also use the appropriate sign, S-I-G-N, for this terminal side that falls in quadrant 3. All right, so let's just get to it. Remember, sine for theta is the ratio of opposite over hypotenuse. So it starts off being 15 over 17, but remember, in quadrant 3, sine is negative, so we got to make sure that we make the ratio negative. All right, cosine, I better put theta here just to make it more precise. Sine theta is this, cosine theta. All right, so for theta, cosine is the adjacent side over the hypotenuse. So we start off thinking that's 8 over 17, but realizing that cosine is negative in quadrant 3, I've got to make that ratio negative. Tangent theta. Okay, tangent is, for theta, it's opposite over adjacent. And for tangent in quadrant 3, we've already shown that it's positive, because negative divided by negative creates a positive ratio. Okay, so now let's work on the reciprocals. The reciprocal of sine is cosecant. And so we just take sine and flip it over. The reciprocal of cosine is secant. So we take cosine and flip it over. And the reciprocal of tangent is cotangent. Let's about to write tangent again. And so we take tangent and flip it over. So the most common mistake that people make is incorrectly putting the sign, S-I-G-N. Again, I'm sorry to keep spelling that, but I don't want to confuse you. You got to be careful to recognize what quadrant you're in and realize what sine, cosine, and tangent are as far as their signs within each quadrant. Okay, let's try this one. All right, so once again, I'm going to draw this xy plane, and we're going to plot the point 0, -4. And this one, we can't really draw a triangle, obviously, because the terminal side falls on this quadrantal. It's really one of our quadrantal angles. Okay, so 0, -4. So let's go back over to our little diagram. And remember, on this particular quadrantal angle, this is always true. Okay, when you're down here on the negative y-axis, cosine is always 0 because that's the x-coordinate of any point on this negative y-axis. Sine is always -1. Now you're thinking, but it looks like it's -4. Well, to get sine, technically you would take this point and divide by the radius of our circle, which if we were to draw a circle, it would be -4. And -4 divided by 4, the radius would be 4, would be -1. So it's just always true. If you end up with a point on one of these, what we call quadrantal angles, the terminal side is actually one of these lines that we call either the x or the y-axis. It's always true that cosine will always be 0 if you're on the y-axis. Sine, if you're on the negative y-axis, will always be -1. Okay, so that's just always true. And tangent, in this case, since tangent is the ratio of sine divided by cosine, we can't divide by 0, so tangent is actually undefined. All right, so now we do the reciprocals. So for our reciprocals, remember secant is the inverse of cosine, and another way of thinking of the inverse, secant is thought of as 1 over cosine, and that's just another way of saying the inverse of. And if we take 1 over 0, which is what cosine is defined to be, then obviously we can't divide by 0, so in this case secant is also undefined. Cosecant is the inverse of sine, and using the same line of thinking, cosecant could be thought of as 1 over sine. That's just another way of saying the inverse. And 1 divided by -1 is -1, so cosecant in this case is -1. Cotangent is the same thing as 1 over tangent. That's just, again, another way of expressing the reciprocal. Or you could think of it as cosine over sine. Since tangent is sine over cosine, cotangent is just the flip of that. Well, cosine relates to x and sine relates to y, and 0 divided by -4 is 0. So I just wanted to give you another heads up. If you end up with a terminal side that actually falls on one of these that we call quadrantal angles, just go back and refer to our previous slide, and I've basically given you what sine, cosine, and tangent will be if you fall on any one of these quadrantal angles. That should help you out quite a bit. Talk about reference angles. We're supposed to sketch the given angle and then find its reference angle. What's a reference angle? Well, it's an acute angle, once again, between 0 and 90 degrees, formed by the terminal side. We talked about what the terminal side of the angle is. terminal side of some angle called theta, and the x-axis. All right, so we're supposed to sketch this angle. So we're going to have to draw our xy plane. And remember how we do 300 degrees. We go in a positive direction. We start on the initial side. Okay, so I'll do it in blue. So starting here, this would be 90, this would be 180, this would be 270, and then I need to go another 30 more to make 300. So I'm going to approximate that to be about 30. Okay, so I'm calling that 300 degrees, and I'm going to draw a little arrow to indicate the positive direction. So that's 300 degrees. So what is the reference angle? The reference angle is this angle right here. I'll just identify it with these two green lines. It's the acute angle, okay, so it's got to be less than 90 degrees. And it's the terminal side, which that's my blue line. It's the angle that's formed with the terminal side and the x-axis. Okay, so if it's a total of 90 degrees in this quadrant, and I've already gone 30 degrees, then obviously the rest of this has to be 60 degrees. So the reference angle would be this 60-degree angle identified by these two green marks. And that's how you will always find a reference angle. It's this acute angle formed by the terminal side of a certain angle and the x-axis. Okay, so the reference angle, the answer to the reference angle, it would be 60 degrees. Okay, let's try another one of those. All right, so let's draw our axes, and we'll sketch 115 degrees. That's positive, so here's 90, and then another 25 would give us 115, so we'll just say that's 120 or 115. All right, so here's my pretty close. That's my terminal side. So this is the 115 degree. My reference angle is the acute angle that's made from this red terminal side and the x-axis. So it's this angle. So how much would that be? So if this is 180 and we went 25, you could think of it this way. You got 90 degrees here to work with, and you went 25 so far into this quadrant. So how much more would it take to make the 90 to get you to the x-axis? All right, so hopefully you're saying, well, that's 65 degrees. Or maybe you thought if it's 180 to here, and you subtracted 115, you could have gotten 65 that way as well. So either way you want to look at it, the reference angle would be measured at 65 degrees. It's the acute angle, once again, I know I'm repeating myself, but it's this acute angle that's formed from the terminal side of a given angle and the x-axis. All right. Let's try these. These are given to us in radians. So you could do the radian measures, or you could convert them over into degrees. You know how to do that now based on a previous lesson. So let's just draw our xy plane, and we'll just look at this in terms of radians. Okay, so remember in radians, this is pi over 2. Because at all the way over here at what we call 180 degrees, this is pi. This is 0, and all the way around, if this is pi halfway around, then this has to be 2 pi radians all the way around. Okay, so we want to know what is negative 3/4 pi. Okay, so if we're going in a negative direction, let me change my marker here. So going in a negative direction, remember we start here at the initial side and we go this direction. So this is negative pi over 2. So that would make this negative pi. And this would be negative 3 pi over 2 and negative 2 pi. So we're going in a clockwise direction for the negative. Okay, so I start here at the initial side, and if I went all the way to here, that would be negative 4 pi over 4, which is another way of saying negative pi. So I don't want to go all the way to negative pi. I want to go 3/4 of that way. So I'm going to estimate that to be about right here. Okay, so I've sketched the given angle. And now what I want to know is, what is this reference angle between the terminal side and the x-axis? So it's got to be an acute angle. It will not be negative. Okay, it's some angle between 0 and 90 degrees, or in case of radians, pi over 2. So what is this in radians? Well, if this is negative 3/4, takes another 1/4 to get to pi. So the reference angle would be pi over 4. It's another way of saying 1/4 pi. Okay, so I don't want you to get confused thinking it's got to be negative. The reference angle will never itself be negative. It's always between 0 and 90, or 0 and pi over 2 in radians. We just want to look at what this angle is between the terminal side and the x-axis. Okay, so let's try another one. Letter D. So once again, we're going in a negative direction, so we can go ahead and label this is negative pi over 2, negative pi, negative 3 pi over 2, 0, negative 2 pi. Okay, so if you wanted to, you could change this into a mixed number. It's already improper. So you could think of it as negative 1 and 1/4 pi. That helps because we know that this is negative 1 pi. And then I just need to go another 1/4 of pi. Okay, so what's 1/4 of this distance? And that's going to be about, this would be half, so it would be half of half. So we're basically talking about this angle here. So this is negative 5 pi over 4. It's negative 1 and then 1/4 pi. This would be negative 1 and 1/2 pi. Negative 1 and 3/4 pi, and then negative 2 pi. Okay, so what is the angle here that's formed? Do it in green again. Between the terminal side and the x-axis, and that would be pi over 4. All right, and that's your answer for example letter D. Okay, we're moving on to the last type of problem, and this will help you with 24 through 31. I went ahead and made a copy of the notes going back to lesson 9.1, where we talked about the special right triangles and the trig ratios that we can derive from those special right triangles, because they're going to really come in handy. So hopefully you won't have to go back and look at your 9.1 notes. I just went ahead and copied that page of your notes so that we can use those to come up with these answers pretty quickly. So we're supposed to find the exact value of each trig function. So let's think about this. Sine 3 pi over 4. What angle, or what does this angle 3 pi over 4 look like if we were to sketch it So once again, this is a positive, and we can just label here we're going in a positive direction. So this is pi over 2. This is pi. And according to this, we're going to go 3/4 of the way to pi. 3/4 pi. So we can do a little sketch here. So this would be 3/4 pi, roughly. So the way we're going to answer these is use this idea of reference angles, because those are going to be usually pretty common. That's why those special right triangles are so handy. We can use the reference angle pi over 4 because we know based on our special right triangle, first of all, we can convert this into, so our special right triangle answers make sense. Let's change this over into degrees. So remember our conversion, we just do 180 divided by pi, and we can do a little canceling here. And so that's the same thing as 45 degrees. Okay. Now we got to be careful because notice what quadrant this terminal side is located in. So let's go to our special right triangle and look up sine 45 degrees. And we're told that that's square root of 2 over 2 based on special right triangle that we looked at earlier. But in quadrant 2, we notice that the sine ratio is always positive in quadrant 2. We talked about that earlier. So we're good by using the answer, the square root of 2 over 2, and keeping it positive, because in quadrant 2, which is where this terminal side is, sine is positive. All right, so our answer for letter A will be the square root of 2 over 2. Next example, that's our special right triangle. We'll come back to that again. And I think pictures help until you get used to these. So let's draw this angle 5 pi over 3. And if you want to change it, it's like 1 2/3 pi. All right, going in a positive direction. So this is 1 pi. And then we're going to go another 2/3 pi. So we're not going to go all the way around, but we're going to go 2/3 of the way around. And we don't have to get too exact. We just need to have an idea of what quadrant this terminal side is going to fall in. All right, so here is the angle 5 pi over 3. And let's convert this. First of all, let's change to the reference angle. The reference angle is this angle here that's formed with the terminal side and the x-axis, and that's going to be pi over 3. In radians, you can always find the reference angle by just looking at this part of your fraction. Makes it pretty simple. Okay, so pi over 3, if we were to change that into degrees, remember we just do 180 divided by pi, and the pi's cancel. That's the same thing as 60 degrees. So what is tangent 60 degrees? So let's go back to our special right triangle, and we know that tangent 60 degrees is square root of 3. However, got to be careful because in quadrant 4, remember in quadrant 4, cosine is negative, just like the x-coordinate. I'm sorry, cosine is positive and sine is negative. Cosine is the x-coordinate, sine is the y. And if you divide negative divided by positive, you're going to get negative. So tangent is negative in this quadrant where this terminal side falls, and so our answer is going to be the negative square root of 3. Okay, letter C. Let's just do a little picture of what 120 degrees looks like. So here we are at initial side. We go 90 and then another 30. We use the reference angle, which is this angle here, which would be 60 degrees. Okay, so we're basically going to find our answer by doing secant 60 degrees. Well, remember what secant is the inverse of? It's the inverse of cosine. So let's find out what cosine secant is. Going back to our special right triangle. Cosine 60, sorry, I said cosine secant. Cosine 60 is 1/2, okay? And we got to be careful that we get the sign correct, the SIGN. We know cosine 60 is 1/2, but in quadrant 2, which is where this terminal side is, cosine is negative. Remember how the signs go in quadrant 2? The x-coordinate is negative and the y is positive. So that means that cosine 60 in quadrant 2 would be actually negative 1/2. Well, secant is just the inverse of this. So secant 60, or the answer here, would be -2. All right, and so that's your answer for letter C. Let's try a few more of these. We'll just sketch out what 300 degrees looks like. All right, so here's, we're going in a positive direction, 90, 180, 270, and then another 30. Okay, so we're going to fall in quadrant 4. We're going to use the reference angle 60 degrees. Okay, this is 30 degrees, because I had to go 270 plus 30. So the reference angle is 60 degrees. So really I'm going to find my answer by doing sine 60 degrees, but I got to make sure that I make that negative because sine is negative in quadrant 4. All right, so let's go back and look at our special right triangle. Sine 60 degrees is the square root of 3 over 2. But since sine is negative in quadrant 4, I'm going to make it the negative square root of 3 over 2. Okay, let's try another one. Here is, we need to draw the angle 240 degrees. All right, positive, so we go 90, 180, and then another 60. Okay, 180 plus 60. All right, so that's 240. Our reference angle will be this angle in red. It's between the terminal side and the x-axis. That's 60 degrees. So it's like saying cosine 60, but in quadrant 3. And in quadrant 3, cosine is negative. Sine is negative also. Okay, so let's go back to our special right triangle. Cosine 60 is 1/2. But since it's in quadrant 3, cosine has to be negative. I'm going to make it negative 1/2. Okay, we're almost done. Let's draw the angle 5 pi over 6. All right, so once again, here's pi over 2. This is in radians. We're not going to go all the way to pi. That would be 6 pi over 6. So we're just going to go almost all the way. I'm going to call that 5 pi over 6. Should be drawing little arrows on these. Okay, so 5 pi over 6 is here, so that means my reference angle is pi over 6. So I'm going to be doing cosecant pi over 6. And remember, cosecant is the reciprocal of sine. All right, and I'm remembering in quadrant 2 that sine is positive. Okay, if you're looking at the ordered pairs, the x is negative and the y is positive, and sine and y correspond. Okay, so let's go back to our special right triangles. Eventually, hopefully you'll have these memorized. And let's think of sine pi over 6. Well, these are all in degrees. So let's do a quick little conversion. Just multiply by 180 over pi. The pi's will cancel. 180 divided by 6 is 30 degrees. So let's look up sine 30 degrees. Sine 30 degrees is 1/2. But since I want the reciprocal, I'm going to make that 2. Cosecant is the reciprocal of sine, and sine is positive in quadrant 2, so that means cosecant is also positive in quadrant 2. All right, so that's it. We finished lesson 9.3. That's the assignment. And I hope this helps you. If you have any questions, let me know.